Guys, welcome back. You're probably struggling with calculus, aren't you? Probably failing. Well, do not worry, because we are here to help you. So today we're going to be talking about existence theorems. Existence theorems help justify other problems in calculus, and there are 4 types that we're going to be talking about today. And they are the intermediate value theorem, the extreme value theorem, the mean value theorem, and Rolle's theorem. We're going to start off by reviewing what continuity is, because it is important to know this for the first 2 theorems. Continuity requires 3 things. First, f of c has to be defined. The limit of f of x as x approaches c has to equal f of c, and finally, the limit of f of x as x approaches c has to exist. First, we're going to start talking about the intermediate value theorem. The technical definition is if f is a continuous function on the interval ab and c is any number between f of a and f of b where f of a is not equal to f of b, then there is a number c in ab such that f of c is equal to c. In other words, if f of x is continuous, then the function f of x cannot skip any values. For example, if we have a function that starts at 6 and you want to get to 10, you're going to have to go through the values 7, 8, and 9 because it's a continuous function and you cannot skip these values. If the function is continuous because f of c is defined, you know that if you start at f of a and you want to get at f of b, there must be some point in between where you have that f of c, as you can see right here. The next theorem we're going to talk about is extreme value theorem. The technical definition is if f is a continuous function on the closed interval ab, then f has both an absolute max value f of c and an absolute min value f of d for some numbers c and d on ab. In other words, you are guaranteed a max and a min. Ding! Go for it. We can see that in this function, it is continuous from point A to B on this closed interval. So we are guaranteed a max and a min. For the next 2 theorems, it is necessary for the function to be differentiable. In order for a function to be differentiable, it is when f of x is continuous and the function f of x has at least one tangent line. For the mean value theorem, the technical definition is if f is a function that is continuous and on the closed interval ab and is differentiable on ab and f of a is equal to f of b, then there is a number of c that is a set of ab such that f prime of c is equal to 0. In other words, f prime of c is equal to f of b minus f of a all over b minus a. Here's another example that would help you understand mean value theorem. So as you can see, we have a graph with the numbers 0, 7, 2, 10, and 4 and 12. So the problem says, since f of x is differentiable, use MVT to prove that f prime of 3 equals 1. Now, it is very important to know that the function is differentiable and that they're asking you to use MVT. Now, we know that MVT means that m secant is going to equal your m tangent. In this problem, they're asking us to find f prime of 3 equals 1, but in the graph, we don't have a 3. Therefore, we're going to use the numbers 2 and 4 because the 3 is in between. Therefore, to find f prime of 3, we're going to use the formula we mentioned earlier. So you're going to do 12 minus 10 all over 4 minus 2, which is going to equal 2 over 2, which is also 1. Using MVT, we prove that f prime of 3 is equal to 1. So once again, we have a differentiable function, which means it's continuous, and our m secant, which goes from a to b, has to equal our m tangent, which is your c right here. Last but not least, we have Rolle's theorem. The technical definition for Rolle's theorem is if f is a function that is continuous on the closed interval ab and differentiable on ab, and f of a equals f of b, then there is a number c that is a set of 8b such that f prime of c equals 0. In other words, keep in mind to go ahead and look out for same endpoints and when there is a f prime of x that is equal to 0. For Rolle's theorem, we have this graph where there is point A and point B and they are the same. There is a tangent line here, here, and here where f prime of x is equal to 0. So let's get some history about these famous super brainy guys. So who proved MBT, you might be wondering? His name was Augustin Louis Cauchy, and he invented it in 1823. The intermediate value theorem was first proved by Bernardo Bolzano in 1817. But Louis Arbogast was the first one to have the idea of how to formulate the IVT and apply it onto mathematical problems. Now, the extreme value theorem was originally proven by Bernard Bolzano in the 1830s. And last but not least, the Rolle's theorem was named after Michael Rolle in 1691. It's a flawless victory. Good job, guys. You now know how to use the existence theorems. Now go kick some calculus ass.